here we go. We are looking at the law of definite proportions and then going to compare that to the law of multiple proportions. Okay? So, first off, we want to see that this states that two elements combine in definite proportions by mass. Now, I showed you that earlier when we did this screen. Right here, okay? So calcium combines with chlorine, and it's always one calcium, two chlorines. There's one group of elements that will do it differently, and we'll get to that with multiple proportions. But this guy you can count on. Calcium and chlorine always going to match up. One calcium, two chlorines. Well, two chlorines is 71 grams, and calcium is 40, and we're good to go. Just divide both sides by 40.1, and you get a 1 to 1.8. Ladies and gentlemen, you can be here, you can be in China, you can be in Japan, you can be in South America, you can be down under with the Aussies, and you could be in Canada. By golly, you could even be in England, or of all places, Russia. Anywhere in the world. That's always the same. So, two elements combine in definite proportions. I just did the MgO for you, magnesium oxide, as a demonstration, which you know is kind of fun. Calcium oxide is the same. Silver chloride. I think we'll do a little mini lab with this guy. We're going to make some of that. That'll be fun. Yeah. We'll take silver nitrate and we're going to mix it with sodium chloride, which is salt, and have a ball. So all of these guys combine according to the law of definite proportions. Now, when we go down to the law of multiple proportions, we have a different group of elements. And those elements are in the transition zone. And what I mean by that is this law also applies to some compounds. Not all. Frequently, one of the elements is a transition element down in the valley. And I will try to get a periodic chart up here real fast. Okay, here we see a periodic chart. Now, you'll notice that I get this little guy. This chart is interactive, which is kind of fun. But I'm making a box right now around what they call the transition elements. Oh, down in the valley so low. Why is it a valley? Because these guys go up here, and these guys are down here. Okay, so because it also applies to compounds, why is it any different? Well, because frequently one of the elements that follows the law of multiple proportions is going to be a transition element. In fact, almost always. And these guys are down in the valley. Oh, what do I mean by down in the valley? I'm going to show you, of course. Oops, not there. I'm going to show you by going to an online site, not here. Here, where are you? Oh, okay. I've got it. There we are. Okay, so here's a periodic table, and in this periodic chart, I'm going to outline the valley. Okay, the valley is down in this area that we call transition elements. And I have a corny little song. Of course, I have lots of corny little songs, so I'm going to sing you this song. Oh, down in the valley so low, hang your head, oh, that's enough. So, it's down in the valley. Now, if you want to hear that again, you can watch my video. All right, because I'm going to put it up today. Now, multiple proportions. Frequently, one of the elements is a transition element. And, strangely enough, my two examples are going to use transition elements. And for those of you here in the classroom while I'm doing this recording, law of multiple proportions applies to copper and chlorine combinations. And copper and chlorine can be two different ways. So, if we look on the periodic chart, you will find copper as element number 29. It's down in the valley. Yeah, you won't forget that, will you? Okay, so down in the valley. Now, copper can have one or two chlorines, and they will be in even numbered ratios. Okay, small, even numbers. So the next thing to look at is that different ratios of mass are always, that is, always small whole numbers. And that's what the law of multiple proportions is all about. Now look at this guy. This is amazing. When we put vanadium on the periodic chart is, where are you, vanadium? Yeah, number 23. So it's a transition element. It's down in the valley, okay? And it combines with chlorine. And it will combine with chlorine in 5 different ratios. And each of those combinations has its own color. And you'll be seeing a video later in the course that allows you to see that. And it's just awesome. You get a mixture of vanadium and chlorine, and you mix it up and you keep mixing it with certain things in there that help this occur, and you see the colors of the different compounds. So this is fun stuff. And multiple proportions is not as complicated as you might think. It just means that you have almost always a transition element that will combine in more than one ratio. And so we call that those ratios are always small whole numbers. And that is it.